Hey, today we're going to go through a really cool end-to-end example of training an object detection model, which is something we can run on our robot. You see several teams that use it to find pieces, to track other robots, to find game pieces, in addition to what we do with April tags currently. Right now, we're looking at a cool website called Roboflow, which makes it really easy to label the images and videos and things that you want to use for model training. And then to train models, like you can see right here, for a variety of use cases, from object detection to tracking, to counting, to analysis, tons of stuff you can do. This can even run on the embedded platforms we have, like the Limelight or the Orange Pi. So let's go through a full end-to-end example of how to train this yourself. Go ahead to the folder, the object detection folder shared in FRC 4419. You can just double click on it on Mac, which will unzip it. You can see there's another folder in there, and there's two files inside of that folder. The first one here is video, and the next one is a test set that we're going to use to validate how good our model is that we train. So first, let's look at the video. This is the Einstein recording from last year. So this is the championship recording. This is pretty easy. A ton of like FRC robots going around. And what we're going to do today is train a model to be able to track and detect these FRC robots, which is something that most models don't really think this looks like a robot, so they have a hard time. So we're going to create a custom model that is really good at doing that. So here you see about 15 seconds or 24 seconds of a clip. I trained a test set, which we're going to validate against, which is the next 5 seconds after this clip is done. So our first step here is going to be going into Roboflow. We're going to import the test set, and then we're going to import the video. Go from there. So back to Roboflow. Here we can use to label and create models that we can run on our device or on the laptop, whatever you want to. You're going to have to make an account most likely. I've already created one, so it signed me in. You just need a Gmail or you need an email password to sign in. Let's create a new project. We'll call it FRC Robots. We're going to be annotating robots, so let's call it robot. It's our tag. We'll make it private. We'll make it public, easy to work with, and then we'll use the traditional tools, so we don't need the fancy AI rapid stuff. We're training an object detection use case. Let's go ahead and make our project. First thing we're going to do is upload the test set that I shared as part of that folder. So if you guys go back to the train object detection folder, you see there's one inside of here. Actually, you probably have to unzip it. The zip file here, which I've already unzipped, called FRC Reefscape. So I'll go ahead and click OK. Wonderful. We'll upload it. Here you see it selecting 51 images that I've already labeled. You can see I went through and dragged through and labeled each one of these robots, which we're going to use to test how well the model is working. So 24 images in total that we use for test. Click Save and Continue. See, we have no training data, no validation data yet, so we're going to create that ourselves. That's the next step. Uploading happened pretty fast. That's great. 24 images, one class, which is robot. We're going to turn off any pre-processing. We want our model to be trained on the same type of video feed that we're running on ourselves, so we're not going to do any changes there. We're not going to augment any data. This is kind of cool. It can bring in similar examples to help you improve your model. That's fancy. We can do that at a later step. Let's go ahead and click Create. So here's our first dataset version, which is just test data. The next step is we need to create training data and validation data. Training data is what we use to train the model. Validation are extra images we use to make sure that our model training is going the way that we want. So we'll want to do about, like, as a general rule, maybe 70%, 20%, 10% split. So let's go ahead and start doing that. So the next step is we need more training examples. Roboflow, where you can just upload a video and it'll extract images from there. So here is that same video we just watched. We're going to do all 60 seconds. You're going to want to label about 75 images probably as a minimum. This is kind of a hard task, so let's aim for that. That's about 3 frames per second. That's just fine. There's so much movement, as you can see here, every second, that there's not a lot of duplication happening. So now for the really kind of time-consuming part, we've created these 75 images. We're going to upload them. We need to go through now and manually annotate each one of those. So this takes time, but as we'll see, it's worth it. And I'm curious to see how everyone else does on this task as well. So ready to start annotating. The auto labeling doesn't work really very well because AI doesn't recognize these robots. So we're going to label it ourselves. We'll go old school. Switch over to the bounding box tool. And what we're going to do here is find each robot in the frame. Click it. You can see it chose robot as the label. So we're going to find each one. The kind of cool thing here is that each one of these robots is so different, but the bases are very similar. So what we want to do here is label the bases. Even when they're obstructed, that's actually really good because it trains the model. Some of these hard use cases, that might be a robot there. I can't quite tell. So I see 5 of them. We'll go ahead to the next image, label these guys as well. You'll get fast at this over time. You can just press enter after you select it with the bounding box. So 3, 4. The tighter your bounding boxes are, the better the model is going to do later. So it'll train it better. So that will affect performance in the end. When you're happy, we've only done a couple here. I'm going to go, for the sake of time, over to one I've already fully labeled. So when you're happy, click add all the images to your data set. Here, we're going to do a split. So we're going to split them. We already have everything in the test. You don't need that. So you're going to do a split between training and validation. That seems about right. Go ahead and add. Okay. So now we've updated our data set. We have a training data set. We have a test and a validation. So looking pretty good there. And we can create a data set version that we can use to train a model. So if we go here, let's create a new data set version. Labeled as no pre-processing. We'll turn off the processing step. Create this like cataloged named version of the data set that we can train our model against. So what the next thing you're going to do is click custom train. Here you can choose what model you want to run on. The Roboflow has its own models. This is the industry standard. YOLO, it stands for you only look once. It's a really nice, like really efficient model. So click that. Here you can see there's different sizes. We'll look at examples of this later, but here you can do fast or accurate. We're just going to do fast. This is always better to experiment with simple, easy models first. It's going to complain about us not resizing, but that's okay because we want to run on the same aspect ratio as our camera. And then let's go ahead and train from public checkpoint. This is interesting. So this model is pre-trained. It has been trained on hundreds of thousands of images from the Microsoft Cocoa dataset. So it already knows about the world. So that's how we can get away with only labeling 75 images and having it training pretty well. So from there, we can go ahead and click train from public checkpoint, start training. Obviously, it's going to do a terrible job here because we only had 3 images that we labeled and 31 we're testing against, but that's the flow that we're going to do. I'm going to jump over now to the project where I already fully trained it, and we can see a couple models that we trained. So this is exactly the same, except in this other project, I went ahead and labeled all of the data. So here we've got a train test split, which you can see here. Let's see, what do we got? No prior processing here. We have a train test split of 59 images in the training set, 15 in validation, 24 in test. That's a good split. So that'll work. So we're going to train on 59, validate against 15, and then compare against the 24 with our model. Next thing we're going to do is we're ready to, so we'll train a model. I've already trained models, so you can see the ones that we trained here. Here was their magic instant model, which did absolutely terrible on the data set. So the mean average precision here, that's a precision recall score of how good the model did at 50% confidence. Super low, 24%. That's terrible. We don't want that ourselves. Here you can see where we trained our own model, things got much better. So here you see it getting up into the 98 percentile range using the more advanced model and the stuff that we were picking. Here's kind of an output of what the model looks like. It processes a video frame at a time. So you can see here, 70%, pretty decent score. So here's a model. We're going to go ahead, just for the sake here of training a model ourselves, we're going to train it directly on our own computer here. We'll use CPU. If you have GPU, it'll be way faster. But let's go up here. Let's go back to the dataset versions. Next thing we're going to do is download the dataset. So this is the first step that we need. Download the dataset. We can download it YOLO v11 format. Download zip to computer. Go. So here you can see it's downloading FRC Reefscape. And let's go ahead and start training a model. So you're going to need to install YOLO. I already have it installed on my computer. So let's do YOLO, install Robotics. Really nice instructions on a bunch of different ways to get this running on your computer, but it's a simple command line that you can run. So use Python. This is the simplest. If you have Python, just do pip install, and then you can use the YOLO tool. So we can get terminal open here. Great. So I'm going to remove this. Okay. I'm going to make a directory called YOLO train, and we're going to move that download that we just did, FRC Reefscape. So you can do this with your file selector if you like to do it. I'm just used to using command line. We're going to move that file we just downloaded right into here and then unzip it. The same thing, if you just folder, double click on it, we'll expand it. That creates a new folder. Inside here, you have a data.yaml, you have test, train, and validation. It's pretty cool. All these images and labels all like nicely set up for the YOLO system to train with. So we are ready. You can make sure that the model works here by just doing a YOLO-H to make sure that it's been installed correctly. So you can see we found it there. It works just fine. I'm going to cheat a little bit, and I've got the commands already saved here. So let's do this. So we're ready to train a model now. I'm going to copy this in and show you what it's doing. So YOLO train data equals, we're going to point at this data.yaml, which is inside the folder we opened up. We're going to train a model called YOLO V8N. So nano is the small model, very small, very efficient. And I'm going to make the epochs a little bit bigger. We can give the model time to converge here. We can always kill model training early if we want to. So let's go ahead and do that. And let's start training. A second for the model to load and download. Nope, we're in the wrong directory. You need to go into this folder that we created here where there is a data.yaml and run right there. Shoot. And I'm going to run that YOLO training again. Okay. So this is interesting. This is never exactly the same, regardless of how you run it. So there's a little bit of noise or stochasticity in the outputs. So we're going to see the model starting to learn. We don't know how fast it's going to pick things up. I will show you as it starts here. We'll jump back to Roboflow, and I can show you what the training looked like inside of Roboflow. So here you can see it's going to train for 35 epochs. An epoch is a single pass over the entire data set. So all of the 75 images that we labeled or 60 that are part of the training data. So we'll see how long that takes. One epoch finishes in about 13 seconds. So this training ought to go pretty fast. You can see here, it is terrible. 1% confidence on the map 50 score. So hopefully we'll see that improve. Here's up to 4%. We're targeting 98%. Let's go back and look at what this looked like here. So we trained a model that got up to 98%. Let's go ahead and see what that training curve looks like. So here you see the epochs as it's training, and then the accuracy that it had. And then you see this like map 50 score jumped way up high, really fast. So it thought it found something. It kept learning and then realized it learned very little. This is actually fairly normal. And then it went for a while. And then you have this kind of like aha moment where it really kind of figured things out. And that was around epoch 13. It got up to 94% accuracy, dipped a little bit as it was like continuing to learn, and then came back up and really converged. You know, here you have like a very steady convergence around epoch 100 here. So this is a lot more training that we're going to do in this example just due to time. But we could have killed this at epoch 100. There was no reason to bring it out to all the way out to 300 epochs, other than that it's cool. So we're at epoch 8 right now. Let's look at how the training is going along. So it went from 2% to 15% accuracy, way back down, still hovering pretty low. It's taking it a while to figure this out. So model training here finished up. I had to pause between the videos. I hit like 15-minute limit. But here you can see, let's go ahead and look at the training curves here. So epoch 13, 70%. So here we've got a big leap in the confidence here. Also at 95% confidence interval, it's still pretty good. We should talk about what this confidence is. So this map 50, essentially what it's doing is drawing a bounding box around the robot, like what you saw. I labeled one myself. So it's looking at how much of the bounding box overlaps with the one that we had provided ourselves. And it uses that to create this confidence interval here. So this means the box like overlaps really well, and how confident really the model turns into how confident really the model is at doing this. We see it dip a little bit. So around epoch 17, you see the map 50 start to dip a little bit, and then it really figures things out. So around 18 here, it's like, oh, got it, nailed it. Something happened. Things started to converge, and we're up at 95%. And as we can see here, for the rest of training, it really kind of hung there. So it had definitely stabilized. We use the term like converge for a neural network when it really starts to figure things out like this. And you can see it converged quite well, staying in the 99 percentile for the rest of the match. So this is pretty good. 35 epochs finished in not that long, 5 or 10 minutes. And you can see the model got output to this, the best model weighting we had. It's only 6 megabytes. It got output to this, this model right here. So we're going to copy that. That's going to be important. And now let's go ahead and try running this on our video. This is kind of cool. So let's go ahead and grab the MP4, the video that we had. And let's find our video. I'm going to copy it right here. So that video that we just viewed, that 20-second video, is now inside of this folder here. So right here, runs, detect, train, weights, fast.pt, source equals Einstein, final, train video, MP4. So we're giving it these parameters to run against. Confidence, we'll start with a low confidence interval. True, show equals true. So we'll see how it did here. I'm curious. This is a hard use case, and it was pretty confident in its findings. There we go. So here we can see this running really fast, actually, and you can see the. I love watching the parts where the robot's occluded, and you can see how it does this really hard stuff where the human's blocking it, for example, things like that. The model very good at generalizing back behind there. If you wanted it to be even better, you could train on more data, create more examples, but I'd say this is pretty good. You can also see the confidence interval. Going through it one more time. You see the confidence interval that the model had as it was processing each robot. This is another good indication of like how good is my model at finding and tracking these things that we want to do. So this is not tracking. This is doing individual frame detection like what you would do on a Limelight. But if you had a more powerful GPU, you can do things like object tracking. So you can keep track of where they are. You can predict their motion and things like that. So we'll do some cool stuff like that in future videos. Give it a try. Let me know if you have any questions. I'm really excited to hear how it goes.